Okay guys, we're back. I'm going to be working a different kinds of problem. This is in the end of chapter 7.5, homework problems in your book, and I'm just going to show you example 28. They're all kind of done the same, but here's the assignment. They're going to give us these values, okay? Sorry, that's messy. That should be approximate. Log base 5 of 3, they're giving us these, okay? Notice all of them are 4 decimals. 4 decimal places is customary for using logarithms, so I'd like for you to get in the habit, especially when we're doing these types of problems. So they gave us that. They gave us log base 5 of log base 5 Brock of 4. Now, what they didn't give us was this one, but you need to know automatically that you can add this into your list. Log base whatever it is, Brock of whatever, because remember I instructed you that log base 5 of 5, log base 3 of 3, log base 2 of 2, log base x of x, always equals 1, and you need to keep him in here, because if you don't, you're not going to be able to solve. So if this was log base 7 of something, you do log base 7 of 7, throw him in there. Okay, so these are what I call our meaningful values. The meaningful values are the Brocks. Okay, those are our meaningful values. These are just the numbers we're going to add together at the end, but the Brocks come into play about how we set this up. Okay, so you're going to use the properties of logs, and all we're going to do is we're going to find some factors of this Brock. We're going to bust this Brock down into some factors, okay? Meaningful factors. Well, what do you mean meaningful? They got to be one of these guys. My Brocks have to be some form or fashion of this right here. It could be squared. It could be, you know, take you take the square root of it. Anything that's going to help you break this guy into meaningful factors. Okay, so I'm going to look at this and I'm going to go, you know what, log base 5. Let's just think logically for a minute. I'm going to take this because I've got a meaningful of 4 and I've got a meaningful factor of 5, right? So we could say, well, let's see what I don't have. I don't have log base 5 of 3. I don't have log base 5 of 2, so 2 would not be meaningful. Okay, we're going to build it like this. I'm going to say the factors that I'm going to use are 5 times 4 times 2. Okay, so 5 times 4 times 2. And you may look at this one and go, hold up, this is not one of my meaningful numbers. You are correct. But isn't 2 the same thing as the square root of 4? So we can use the 4 meaningful Brock, but we're just going to put a radical over him. So here's what we've got now. Log base 5, factors 5, meaningful because I've got that, times 4, meaningful because I've got that, times the square root of 4, and that's going to give me the 2 that I need. Okay, I don't have a 2 up here, but I can create one. So now that's multiplied, multiplied. That means we're going to separate them out by addition. So you're going to have log base 5, 5, plus log base 5, 4, plus log base 5, the square root of 4, so you're going to say 4 to the 1/2 power, because that's the same thing as saying the square root. Alright, so then we're going to say, I know that turns into 1, okay, plus we have here, log base 5 of 4 is 0.8614. You're just going to convert that back into whatever's given to you. And then this guy's going to come in the front. Remember, he comes in the front, so it's going to be 1/2 log base 5 of 4. Well, log base 5 of 4 is 0.8614, but we're going to take half of that. All right, so we're going to take 1 plus 0.8614. All right, I'm going to go ahead and take half of this first. Okay, 0.5 times 0.8614. Okay, that's, oh wait, I think I'm in radians. I better get out. Okay, 0.5 times 0.8614. I took care of that. Plus 0.8614 plus 1, and the final value is 2.2921. And yes, we need all 4 decimal places when you're doing these kinds of problems. So the trick here is to create a Brock. However you have to do it, but you have to do it using these guys, and of course you're going to add your same base and your same Brock to the problem if it's not in there. This is going to be included in your inventory of things you can use. Okay, so don't forget that. All right, let's see what else we have for you. Let's do another one of those. Okay, This is problem number, let's see, 29. Same section, okay? This is in your book, chapter 7-5. And you can practice any of these in the book you want. All right, so we had the same thing. We have log base 5 of 3 is equivalent almost approximately 0.6826, and log base 5 of 4 is approximately 0.8614. Now all of them in this section are using these decimals, so your meaningful numbers will be the same. And this is log, I'm going to add log base 5 of 5, and I know that's going to equal 1. Okay, so now I have my Brock, and my Brock in the problem is find log base 5 of 30. Okay, so we need some factors of 30. Well, this is easy. I've got 5 times 6, right? So 5 times 6 is 5 times 3 times 2, and we've already dealt with the 2 because that's the same thing as saying the square root of 4. Okay, so we're going to set it up just like that. We're going to say log base 5. We're going to expand this Brock out into 5 times 3 times 2, which we're going to write as the square root of 4 because we have a 4 and we can take the square root of it to use it. Okay, so this is going to give us log base 5 of 5 plus log base 5 of 3. I'm using addition because remember, multiplication turns to addition when you're expanding. And then that's going to be plus log base 5, and 4 to the 1/2 is the same as taking the square root of it. All right, same thing. 1 log base 5 of 5, easy, plus log base 5 of 3 is approximately 0.6826, plus this 1/2, remember the exponent rule, it becomes 1/2 times the value of log base 5 of 4. So log base 5 of 4 is 0.8614. Okay, so if you add 1 plus 0.6826 plus half of 0.8614, you're going to get 2.1133. Okay, and that's 4 decimal places. Okay, so the meaningful values, these are the guys that you're going to create your Brock and have them turn into these. And remember, you can take the square root of something, you take the cube root of something, because we know what to do with these guys now. So there's your meaningful values, and you must always create him. Okay, same log base b of b, same Brock, same base is always going to equal 1. So that's really helpful that way. All right, I'm going to pick out a couple more problems to solve, and I think you'll be good to go. Okay, let's see what we got. All right, here's another Rex. This is not in your book. These are from resources that I have. Okay, log base, I don't remember what Rex this is. 3 or 4 maybe? I don't know. Let me look back and see. So y'all keep track of it. All right, that's Rex number 1. That was Rex number 2. Rex number 3. And then the others I came out of the book, so there really aren't Rexes. So this would be Rex number 4. Okay, Rex number 4. Solve. Log Brock 4x squared plus 4 minus log 2 equals 1. Okay, somebody in here is going to go, wait, where is the base? I don't see a base. Well, guys, I've told you countless times that if you don't see the base there, it is automatically a base 10. Okay, automatically. But we don't write it. Okay, so it's just like, you know, when you say 5 cents, you don't write the cent sign anymore. So it's just log base 10. Okay, so that means we have subtraction, which means division. So write the left side in terms of the single log. You will have 4x squared plus 4 over the next Brock of 2 equal to 1. So you're sitting there solving, and you're like, I don't know what I'm doing. I'm stuck with this log. I can't do anything. And then you go, wait, light bulb. Miss Smith said if we're stuck in one format, put it in the other. So you're going to get rid of that. This base is going to travel over here and push that exponent up. So you are left with 4x squared plus 4 over 2 is equal to 10 to the first, which you know just to be 10. Okay, so you have 4x squared plus 4 over 2 is equal to 10. We want to get rid of the 2, so we're going to multiply both sides by 2. Now remember, you're not raising it to a second power again over here. So 4x squared plus 4 is now equal to 20. We've got a quadratic situation, but this is going to be super easy because we have a quadratic and a constant. So you don't have to factor it, you just use square root property. So 4x squared minus 4 minus 4, okay, boom. Oh, sorry, that's what I meant to slice out. 4x squared is still with us. Is equal to, and that's going to give us 16. Divide by 4, x squared equals 4. Square root of both sides, what do we take and put in front of the square root sign? I know you said plus or minus, that's correct. So x equals plus or minus, whoops, 2, we don't know. So we have to test it. So let's go back and look. Okay, if we put negative 2 in here, negative 2 squared is a positive 4. Any kind of negative that's squared will give you a positive. So don't think just because you got a negative value that it's not right. You put a negative in there, it's going to give me a positive 4. Okay, and so positive times positive will be positive. So we are good with either one of those values. So you would say plus or minus 2. Whoops. There we go. Okay, that's my video set for now. This should get you going. I'm going to post them right now, so it'll take me a minute, and then I'll send the attachment. And I want you to do all the problems on the attachment. Okay? And if you want to practice some more of those decimal ones, like where you have to break the block down, go in your book and look in that section. I gave you 2. They're all done the same, but please don't say we never did anything like that, because now you have 2 solid examples. Okay, I'm out. Bye. Don't forget, we have a team meeting at the beginning of each class tomorrow. Be on time.